So you had to stand out a little bit. You had to demonstrate that you were willing to make a sacrifice. And one of those sacrifices was, famously, you didn't really get paid to do your internship at Reynard. I doubt that's legal anymore. But you didn't get paid. It was pretty voluntary. Some people got living expenses and a living wage to cover their accommodation costs. But that was kind of the hardship that the business wanted to see you put yourself through, to be committed to wanting to have the job.
In February, I headed down to Silverstone to have a chat with the CEO of the Digital Manufacturing Centre, Kieron Salter. I was there to interview Kieron as part of a documentary I was making about Reynard's LMP project, a project he had been involved with from its inception as the technical manager of Reynard's Special Vehicle Projects division. If you haven't seen it already, you should check out that video. While a lot of our conversation dug deep into the specifics of that programme, the story of Kieron's time at Reynard and subsequently KW Motorsport, KW Special Projects and ultimately the DMC is a fascinating peek into the inner workings of the motorsport world, as well as the immense cross-industry application of the skills and knowledge acquired in such a high-pressure engineering environment. I learned a lot from our conversation and I'm sure you will too, so without further ado, let's jump in.
So I'm Kieron Salter. I'm the CEO and founder of the Digital Manufacturing Centre and also KW Motorsport and KW Special Projects. So I graduated in mechanical engineering at Oxford Polytechnic, well actually Oxford Brookes University as it was by the time I graduated in 1993. And I kind of wanted to go and work in the automotive industry, and I was applying for jobs at people like Ford and Aston Martin and Jaguar. None of which actually paid off at the time, but fortunately on the day that I graduated I bumped into a guy called Adrian Reynard. Adrian was guest of honour at the day that I graduated. He was doing a little speech about his company, and I learned about Reynard Motorsport, which I hadn't really been that familiar with until then. And I thought, well, that sounds like quite a cool company to work for, and so I asked Adrian for a job whilst I was collecting my certificate off him. So I ended up working, I went to Reynard and met with Adrian and got introduced to his graduate training program, which was fairly harsh, but back in 1993, that was how you got into motorsport, was you essentially volunteered for a few months and found your way into the business through demonstrating your desire to work and capabilities. When I stepped in the first time, there wasn't an IndyCar program at that point. It was Formula 3 and Formula 3000 cars that were being built. I remember it quite clearly because it was like a toy shop. It was and a sweet shop. When you first walked in as a junior graduate engineer, there probably weren't many more exciting places to go and work if you're into cars and motorsport. But also as an engineer, and I think it's important that the choices I made about where I wanted to work and why I actually fell in love with the motorsport world for engineering was because it was a really good place to be an engineer. And I like problem solving and engineering first. Cars just happens to be something that I'm also passionate about. But you find there's two camps of people in this industry. There's people that perhaps wanted to work in motorsport because they wanted to be racing drivers, or they do race already, but this is a good career path for them. Or there's the ones that want to do it because they're good engineers and it's a good place to practice engineering. But when I walked in, there was, I remember going into the stores, for example, and just seeing all these amazing pieces of what looked like jewellery on the shelves of, red anodized, good rich couplings and blue anodized couplings and stainless steel and braided parts and discs and calipers. And it was fascinating. And then actually working in with those cars and being part of the build process and working with the engineers was really rewarding, because you got to see things happen from drawing to going on the car in the matter of weeks. And what was really, I guess, quite unique to Reynard was that you were given an awful lot of responsibility very early on. You weren't remunerated for that responsibility, perhaps in the right way, but you were given a lot of responsibility, and that gave you a lot of opportunity to learn, make mistakes, and learn from those mistakes. And those that grasped that opportunity, I guess, went on to be quite successful in their careers. And there's a number of people that have been through that graduate training program that work in reasonably high roles in Formula 1 now. Anyway, that worked out, and fortunately I ended up working for Adrian for nearly 10 years. I started off as a graduate engineer, as a project coordinator, working on the Formula 3000 program. It didn't seem like a particularly glamorous job to start with. It's sort of a bit of an admin job within the drawing office, but of course it put you right in the middle of the drawing office, working with the engineers, the experienced engineers, on both IndyCar and Formula 3000. So I was the project coordinator, which meant bringing together all the bill of materials. I saw every drawing for the Formula 3000 car that year came across my desk, and I had to check those drawings, enter them into the system, prepare them for manufacturing. And so I was the liaison between manufacturing, build, and the drawing office. So it's a fantastic opportunity and a fantastic place to learn your engineering trade, essentially. The main drawing office, and I remember this quite clearly as well, because it was exciting, but also brutally disappointing at the same time, really, because you went into the drawing office as project coordinator. You see there were desks with partitions between them, so a bit less open plan than we perhaps now are used to, certainly the offices we've got here. So people had their little cubicles and they had paper plans pinned to the boards in front of them, and there was lots of paperwork and calendars. Everybody had calendars. Big computer monitors, right? So most people won't be familiar with how big computer monitors used to be. To get a decent sized screen to look at on a CRTV, you also had a load of depth in the monitor behind. And we had Unix workstations, not PCs. So they were bespoke to CAD. We had a plotter in the office where all the drawings were plotted out, and then we also had a copier room where you had to take the drawings to get them copied onto formats to be sent to suppliers. But each engineer had their desk, and it was organised. IndyCar and Formula 3000 were in the same office. And the bit that was brutal about it is you look around as a graduate engineer and you think, when is there ever going to be a place for me? Because none of these people are going to want to move on. No one's going to leave. How does a job as a design engineer ever come about? So that was the bit that was a bit daunting about it. But for as long as Reynard was around, because I guess 93, I finished in Reynard in 2002. We only just, it sounds surprising, but only just in 2002 were we really getting into fast broadband and fast internet. Up to that point, it was all still dial-up. I think when I started at Reynard, we didn't have the internet. We certainly didn't use email. Everything was still done by fax. And for a long time, actually, even into the late 90s, with it's an important bit I've missed out about what was in the drawing office. When we were into IndyCar, there was a fax station where all the technical bulletins would be sent and come into from North America and from our American team friends over there. So the fax machine was an important part of communication back then. So office tools were different. The environment wasn't a lot different in it, as much as it was about people and about people talking to each other. And at Reynard, we did have two different drawing offices. There was the one for the IndyCar and Formula 3000, and eventually we set up a separate drawing office for special projects. But it was only, I think, about 60 or 80 people when I joined. So Reynard was just finishing off doing Formula 3. Formula 3 category had become dominated by Delaras, I think it was. Or maybe it wasn't Delaras. Can't remember that one. But Formula 3000 was still quite buoyant, but Formula 3000 was on its way to becoming a one-make series. But Reynard dominated Formula 3000. There were two constructors really in that field. There was Lola and Reynard, and Lola and Reynard were kind of arch competitors or arch enemies for a very long time on the racetrack. But when I joined in '93, Reynard had come out of an attempt to get into Formula 1, which wasn't successful, which had knocked the company a bit. But they had identified IndyCar as an opportunity, and so IndyCar was just about to start to get going within the business, and so it was a hugely exciting time. I remember at Reynard in sort of '94, '95 as preparations were happening for IndyCar, and then when the first IndyCar was delivered and raced in Australia, we all sat and watched that race, and Reynard went on to win the first race of its IndyCar career as well. So it was fairly much an open door. So there wasn't a prescribed scheme as such in terms of nowadays, there's a certain number of opportunities available. They're very, very well organised by HR departments. They're very corporate, certainly within the Formula 1 world, and they're very well organised. But then it was really Adrian's initiative to make sure that he got the best of the best. And essentially, you had to make an application to Adrian in some way or to the business, and that happened in a number of ways. So mine was I bumped into Adrian at an event at my graduation, but there were several Australians who worked at Reynard at the same time as me who had literally flown to England to come and knock on the door and ask for an opportunity to learn. And that's the kind of commitment that I think Adrian was looking for. So you had to stand out a little bit. You had to demonstrate that you were willing to make a sacrifice. And one of those sacrifices was, famously, you didn't really get paid to do your internship at Reynard. I doubt that's legal anymore. But you didn't get paid. It was pretty voluntary. Some people got living expenses and a living wage to cover their accommodation costs. But that was kind of the hardship that the business wanted to see you put yourself through, to be committed to wanting to have the job. And I can't remember how many people were in the same year as me, but I think it was maybe 3, 4 or 5, something like that. But it was a constant stream of new graduates coming in, and I think probably only half of them made it through to actually staying on for jobs at Reynard. And I think that was for many reasons. Some already got the experience they needed within the first period of time to go off and find a job elsewhere. Some felt it wasn't for them and that they were perhaps being exploited. And others just, no matter how hard they wanted to be part of it, just didn't have the capabilities or perhaps the demonstrate the commitment, so they didn't get picked. But basically the gig was that you had 6 months to prove yourself, and you got a fantastic opportunity to spend literally 1 month at a time around each different department in the business. And that gave you a full working understanding of how the business works, from drawing office right the way through to stores and delivering of cars and parts. But it also gave you the opportunity to meet all of the people in those teams, perhaps identify an area of the business that you may not have thought you wanted to work in, that now you think is really interesting and exciting, and you do, and prove yourself to those people. And so it was really a 6-month interview where you had to find somebody that wanted to sponsor you and take you on board and say, actually, do you know what, I'd like to employ this guy to be part of the business. And there were 2 people in the year that I was there, I guess, that me and a guy called Mike Garth, who particularly found an interest in sort of the IT, the systems, and were able to contribute, I guess, probably because of our youth. We were into sort of databases and Excel, which some of the older people established at Reynard hadn't grown up with. And we were able to bring some of that modern understanding of the office tools to help with bill of materials planning, timing planning. And a guy called Peter Morgan, who sadly passed now, he sponsored us, me and Mike, and said, I would like you 2 guys to come and work in my department as project coordinators. And it was a completely new job that was created within the business when Mike and I started as project coordinators. I did it for Formula 3000. Mike was project coordinator for IndyCar. And our job was, we were the gatekeepers, as I said earlier, between the drawing office and production. And Peter Morgan was production director. And that role at Reynard's remained until Reynard ceased. And it was always the job that those graduates and interns moved into as a route into working in the drawing office as an engineer in some way. Beyond Formula 3000 project, I then did a similar thing for special projects, which was everything that wasn't a single-seater. And at that time, it was a program we were working on called the Chrysler Patriot, which was what we would now call a Garage 56 Le Mans prototype. But it was essentially an LMP car with a gas turbine engine supplied by NASA, I think it was, and a mechanical flywheel storage system, which we now would call that a KERS system. But the mechanical storage system came from satellites. They use them for storing energy in satellites in space when there's no solar power. So it was quite an advanced project. Again, fantastic opportunity to learn quite a bit about other sides of engineering. But that got me into what became Reynard Special Vehicle Projects. Beyond the sort of early career days, I suppose, I think I was there probably, what did I start? 1993 when I joined at Reynard. And by 1995 I was working in the drawing office as a design engineer on the Patriot, which was the Chrysler program, a project called the Strathcarron road car, which was quite an early concept, and the Ford Indigo, which was a Ford concept car, and then we landed the Ford Mondeo touring car program at Reynard, and so I became a design engineer, senior design engineer on the Ford Mondeo touring car program for 95-96. I think the first year that we raced the car was 97, 96 or 97, I can't remember the exact dates now, but it was Ford Mondeo British touring cars in what was pretty much the peak times of super touring at the time. There were quite big budgets, there were big teams playing in that field. There was Audi with the four-wheel drive Quattro cars, there was Ford with the V6 Mondeo, there was Nissan, there was Renault. Renaults were being built by Williams Engineering at the time. So it was really exciting times in British touring cars, and actually British touring cars was stuff that I'd grown up watching on TV, because it really, you know, on mainstream television then you only had Formula One and touring cars, and so BTCC was pretty cool to get involved with. 96, 97 I then became chief designer on the Ford Mondeo touring car. We had Nigel Mansell driving for us, which was pretty cool, because I'd seen him come up through the Formula One when I was sort of fixated to TV watching Formula One. I mean, we're always looking for new markets and new customer car opportunities, and I say Formula 3000 and Formula 3 had become one make championships, so there wasn't really an opportunity unless you were able to win that contract, and in both cases Reynard hadn't. So looking at other categories and race series was always on the cards, and we worked with this guy Don Panos for a number of years then on the Panos GT1 program, and Don, when he came into racing with his Panos GT1 Aspirante car, also became heavily involved in motorsport as a promoter and a track owner himself. So he was very much the driving force between the partnership between the American Le Mans series and European Le Mans as a single race, and the ACO, and that just started to bring the world together in sports car racing, and it created a market. So we went after that market with the knowledge of, you know, having raced in the separate series beforehand with the GT1, and you could build a car that was pretty much common in regulations then. You can now as well, but you know, it was the first time before you'd had Le Mans, FIA, you had IMSA. So we developed a car, well, the plan was to develop a car that could be raced both in Europe and in the USA under the American Le Mans series and Le Mans. And that was the start of my sort of passion with Le Mans racing. So we were doing GT1 with Panos. We had also decided to do a Reynard customer LMP car for racing in the States in the IMSA series. We'd imagined only being an LMP1 car at that point. So at this point, I was technical manager of Reynard Special Vehicle Projects, and I'd been technical manager from the point where I'd stopped being chief designer of the Ford Mondeo touring car, and we had a bunch of other programs underneath Reynard Special Vehicle Projects that all had their own individual technical teams, and then I had overarching responsibility for all those. 1999 was, well, actually I guess it started late 1998 when we did the concept work. It was a troubled car, the 2KQ. There was a few things we got wrong, and you know, you got to pick a strategy and pick a set of targets, and if you pick the wrong one, it's the same in the Formula One now. You know, when a new set of regulations come out, some people get it absolutely right, and some people get it completely wrong, and it's a long road of recovery if you've chosen the wrong strategy, particularly around aerodynamics. And with the 2KQ, the bit that we got wrong was the aerodynamic strategy. I mean, Reynard, as a constructor, had an awesome reputation of building some of the best, finest, you know, customer race cars, and I don't know the exact history records, but almost every championship and every new car introduced had won its first race as a Reynard constructor, and it had become a bit legend. Even the IndyCar, you know, in '95, which was a tall order, went out and won its first race. So, and there was a bit of an expectation, perhaps that would be the same with sports car racing. So selling 10 cars off plan before we'd even sort of tested or had any customer drives in the car wasn't necessarily unusual, because there was a lot of expectation of the ability. Most of those cars were sold into American customers for the American Le Mans series. There was a much broader amount of racing in the States than there was in Europe. Really, in Europe, it was just the Le Mans series. But so they'd all been sold to American customers, and unique to, well, not unique, I suppose, to sports car racing was that they're all different engines that customers could choose from. And we had a similar thing with IndyCar, but there was a prescribed number of engines, and there wasn't really an expectation you'd have to go and do an awful lot of testing with those cars, because your customers do quite a lot of that testing. But I think the problem was the gap between what customers expected in that particular market and what we expected was normal in terms of a customer that might be prepared to go and do IndyCar racing, for example. So yeah, there was a big gap in expectations, and the car, as I say, didn't have the right aerodynamic strategy, unfortunately, and to start with, and it was polarizing in some customers' opinions on what the future of that car might be. It's very carbon intensive, so it was a carbon monocoque. All of Reynard's cars, certainly in the period that I was there, and certainly from the early 90s, were carbon monocoque cars. And they were all made in house. So it was a carbon monocoque, carbon bodywork. The aerodynamics, we were pioneering quite a lot of CFD for the development on the aerodynamics, as well as wind tunnel testing. So we had a 40% scale model wind tunnel program, which was run at the Shrivenham wind tunnel, which was a Reynard tunnel, complemented by CFD techniques. And in addition to that, we had a couple of innovations that were focused on endurance racing and some of the unique aspects of endurance racing, one of those being reliability. And Audi had pioneered at Le Mans around the same time this concept of being able to change the entire back end of their Le Mans car in less than a few minutes during a pit stop, should they need to. And the reason they did that is because it was difficult at that time to build a reliable gearbox that could do 24 hours under the stresses of a sports car. So rather than solve that problem, they solved the problem of how do you change it quickly if it goes wrong. And we took a similar strategy, but we couldn't afford, for our customers couldn't afford to do it in the same way that Works Audi were doing it. So Audi would do it by basically having an entire back end of the Le Mans race car ready to bolt on, and a quick change of the entire rear end, even to the point where they had all the tools were laid out in the right way. It was completely orchestrated so that you could change gearbox quickly. We came up with a concept of, rather than just changing the whole back end, could we just change the gearbox and make a quick change gearbox as part of a feature of the car, which we did. And we did that with a company called Gemini Transmissions in Brackley. And basically our gearbox casing, rather than being structural, as they mostly are now, and certainly were on IndyCar, we made the gearbox casing plug into a carbon fibre monocoque on the back of the car. So we had a carbon monocoque for the safety cell, then you had the engine and some engine frames, and then you had another carbon monocoque at the back of the car which held the rear suspension and the rear wing and all the structure, and the gearbox basically plugged into the back of that on a set of drawer runners from like a kitchen drawer, and you sort of hook it in, push it in, and then it would engage with the input shaft and you're ready to go. And so the theory being you could pull a gearbox out, plug a new one in, and lose minimum time in the pits, because Le Mans racing at that time was all about how long do you spend in the pits, and you usually won the race based on the minimum stay in the pits over that 24-hour period. So that was one of the innovations and concepts. That became very useful at Daytona that first year because we had issues with the gearbox, and I think we changed it about 6 times. Quite often the history books for a project don't tell quite an accurate story of, I suppose, what was originally intended. And sometimes, if you get your PR wrong as well as your strategy in terms of the car wrong, it can be quite catastrophic. And that's really what happened with the 2KQ. So the original plan with the 2KQ, and a legendary designer at Reynard and Chevron, Paul Brown, was chief designer on the car. His concept was to have a very, very high downforce what he called, in fact, a street fighter ALMS car for the American circuits, which were generally slower, more twisty, and would benefit from having superiority in terms of downforce. So the original concept of the car, the one that we built first, was going to America to race at Sebring and Daytona and other circuits. And that carried this high downforce kit. And the high downforce kit had, if you ever look at some pictures of it, this enormous splitter on the front and a very bluff wheel arch. And that was all to generate front downforce, because generally you were front downforce limited. You could generate quite a lot of downforce on the rear with just a big rear wing, but you had to balance it at the front. So the original car was a very high downforce aero package. That's the 2KQ. The compromise of high downforce is usually it also comes with high drag. So this was also a high drag car. Now, there were two problems I think we had. First, with limited testing, we had difficulties with getting the front splitter to work effectively, because it was a big structure. It was flexing a little bit. When it flexes, you get porpoising because you get the aerodynamic surfaces changing a lot. So it wasn't easy to get a balance. Sometimes you could unexpectedly lose front grip, and those sort of things aren't good for predictability in a race car. But also it was draggy. So places like Daytona on the banking and the straight lines, it wasn't fast enough. That was the high downforce aero pack, but we had already in plans and in the wind tunnel the Le Mans kit, the 2KQLM kit, because we knew that by the time we'd finished at Daytona and Sebring, next stop for some of those teams was going to be Le Mans. And you need for Le Mans, absolutely, you need a low drag, which then means a lower downforce aero pack. But we never got the opportunity to explain that's what was coming next, or to demonstrate that was coming next, because post Daytona and the difficulties we had at Daytona, the American market really blew up and criticised the car heavily in terms of its aero package. And so we needed to do something to solve that problem and solve the PR issue that was sort of being associated with the car. And so at that time, I hired another guy in to come and help us with the engineering, a guy called Nigel Stroud, who had been around sports cars for a long time and also worked with us on both the Ford Mondeo and the Panos. Very much an aero-driven chief engineer. So he came on board to bring forward that Le Mans Aero package, because that was now going to become an update for the car generally, and we were moving away from the 2KQ high downforce kit. And I also brought on board somebody to go out and support all of our customers at the track, a guy called Will Phillips. And I'd worked with Will again in touring cars. He was chief engineer at West Surrey Racing when we did the Ford Mondeo touring car. So he went out and started looking after the customers and making sure the cars were set up properly. So giving the customers that support they needed to develop the car. Nigel was working hard in the wind tunnel and on some updates around the car to improve it, because one of the other things we found that the monocoque wasn't as stiff as we'd like it to be, and it needed to be. So we made some updates on that. We also need to update the gearbox, which we'd had some reliability issues. So by Le Mans, our focus was Le Mans Aero kit, improved gearbox, reliability, and fix the chassis stiffness. And all those things were done, and the car ran in its aero first Le Mans kit in its 2KQLM spec with Stefan Johansson. Well, we had 5 cars at Le Mans that year. We had Stefan Johansson, Jim Matthews, and Guy Smith in the Privateer 2KQLM, which then became the O1Q. Judd, and then we had 2 Mopar powered cars being run by Chrysler, and then the 2 Volkswagen cars as LMP 675. All of those carried the updated Le Mans kit. So that was quite a high pressure time. That half of that first year was getting those cars up and running, and then that package was slightly further updated again for 2001. So that all happened in 2000, and we took the opportunity to rename the car at that point so that it didn't carry the same stigma of the previous project. But that became the O1Q. The biggest difference between a 2KQLM and an O1Q, primarily it was just the name, but actually there were some differences. So the 2KQLM was, I guess, the most purest form of the original race car. So the biggest difference between a 2KQLM and an O1Q is when was it sold. We remarketed and was selling the car in 2001 as an O1Q. It had some updates, as an LMP 900 car. But of course, the 2KQLM with the big Volkswagen engines never changed. They were originally commissioned in 2000. So they had all the same aerodynamic updates that we developed for the O1Q, or became adopted by the O1Q. But we weren't remarketing it as a 900 car at that point. So there were some other differences though between the 2KQ LM as a Volkswagen engined car and in LMP 675 than the 900. So it had a slightly different aero pack. So it had the same front end treatment, but actually if you look at the cars closely, compare a 900 car to a 675 car, the rear wing was lower. It was also smaller in section, so it was lower drag. So the 675 cars, although they were lighter, they didn't have as much power. So they had about 500 horsepower compared to a 900 car, which was about 650. So to be fast on a straight line at Le Mans, you need low drag because you had less power to push the car along. So if you look at the cars, they were different. The rear wing was completely different, as I say. There were a couple of other mechanical differences on the car. So 900 car, being a heavier car and more power, had bigger, stronger uprights than the 675 car. The 675 car had the same uprights that we developed for the original 2KQ and maintained those throughout the whole thing. And same gearbox as well, so it didn't carry the gearbox updates, all the gearbox updates that we did for 900. So there were some subtle differences. And then of course we tried to keep the 675 car as close to 675 mass as possible. But it was never designed to be a 675 car. It was designed to be an LMP 900, and as a result was crash tested as an LMP 900. So it carried a little bit of extra mass in the chassis that we couldn't eliminate. But no, they were essentially the same baseline product, but the O1Qs that we marketed in 2001 carried slightly different updates, I guess, than the 675. We did, actually it reminds me, we did have another 675 car. So the Dick Barber Racing V8, I should remember this one well because it was equally successful in 675, and it won the American Le Mans Series Championship. And we had Eric van der Poel, John Graham, Milka Duno driving that car in the States with Dick Barber Racing. I think there were two cars, in fact there were two cars racing in that championship, and it had a very distinctive airbox on that car, which we didn't run on any of the others. So the 675 Volkswagen cars had 4-cylinder turbo engines. The tiny little 4-cylinder, you would never believe it developed 550 horsepower or whatever it did. It was a 2-litre 4-cylinder. It looked completely dwarfed in the engine bay of the sports car. There was so much space around it. But because it was turbocharged, it had a different intake system. It wasn't forced induction. We didn't have a restrictor in the same way as the normally aspirated cars. So the one that ran in the States, the American Le Mans Series car, had a Judd V8, and it had an airbox system with quite a pointy airbox, like a Formula 3 airbox system on it, with a restrictor. So that's how you spot the two differences. But that was also a true LMP 675 car in terms of the same aero pack as the Volkswagens. That first year we'd been at Le Mans with the LMP 900s and the 675 cars. LMP 900 was a very competitive area to be. There were some strong manufacturers in the field with Audi at the front of the grid and Bentley coming on board. But the 675 car had demonstrated that it could be super competitive. So when you bear in mind the second year with that car, we won first year with the car, it was leading its series, but it had some reliability issues with the engine. But the second year, when it won LMP 675 and finished 5th overall, it was overweight, wasn't aerodynamically optimized for that set of regulations. And when you did the maths, it was quite clear that if you built a pure LMP 675 car with no compromise, it should actually be able to win Le Mans outright. And MG had the same revelation with the Lola AER powered car, which was super fast. It was much quicker than the Volkswagen Reynard at the time, but it was fragile because they had built it to be as light as possible. And there was clearly some other compromises in there with the engine or whatever the package was, but it was really quick, but unfortunately never won Le Mans. I think it could have won. That car could have won Le Mans outright at its time. But we'd seen what happened with that. We'd seen what was happening with Volkswagen. We had Volkswagen support with the engine. They were very keen to do something with it, and it was Le Mans and Adrian Reynard, myself, Will, a guy called Otmar Safter, who worked at Reynard at the time before he became a Formula One team principal, and the head of Volkswagen Motorsport. We flew back from Le Mans with Adrian on his jet, and we discussed the opportunity of doing something around a 675 car for Le Mans that was a no compromise. What would Reynard do with all the resources that Reynard had, particularly around aerodynamics, to build an LMP 675 customer car that in theory could win Le Mans outright.
How much similarity was there between the 01Q and the 02S? Were they completely different cars, or was there some carryover?
So they all had four wheels, a gearbox and an engine. There was no carryover. We started with a complete clean sheet of paper. The philosophy had to be no compromise, as much as that's possible within the confines of the fact you've got to be able to sell a customer car at a reasonable price, and you've got to be able to build them. But there was no carryover. We had to develop everything to be close to being on the limit with the sort of the 675 kilo weight limit in mind, and at the same time as I say no compromise, there was a compromise, and that was we felt it was important both from a safety point of view and from a longevity point of view with the car that the monocoque was crash tested as an LMP 900 monocoque, and that was important because Reynard was very focused on safety, being customer cars, but also it meant that you did have a monocoque platform that could be used across other championships and other series if you wanted to run it as a 900 car. So that was a small compromise, but it was a compromise that was worth making because it was a mass in the centre of the car anyway, it was stiffness, and we just had to focus on everything else. But we developed a bespoke gearbox for that car with Ricardo. Ricardo had built the gearbox for Audi, and we selected Ricardo to work with us on that. So a lightweight structural gearbox. We had engine options that were both V8 and 4-cylinder, so we had the Volkswagen, and we were also working with Zytec, which is now Gibson technology, on a V8. There were a couple of other engine manufacturers that wanted to do programs with this, and we got one 4-cylinder engine program that advanced quite far but didn't have funding, which would have laid the engine down flat and reduced the CFG of the car even more. But everything, suspension, uprights, aero pack, big focus on aero package was bespoke. And I guess the two key things, apart from the mass, the things that we're focused on as an engineering team which made the car as good as it was the aerodynamics in the first place. So very, very high LOD. And we achieved that by exploiting the asymmetric aero regulations that BMW had pioneered, and so had Lola. And also minimizing polar moments of inertia. So we focused not just on total vehicle weight, but keeping the mass of the large extremities on the large overhangs to a minimum, whilst being structural. And those were the two key elements that really made that car so competitive. Before I go any further on aerodynamics, I should also make sure I don't lay claim to being the aerodynamicist that pioneered or that really made this car so successful. The two key technical people that really drove this car were Will Phillips, who was the chief designer, who I'd obviously brought in as part of the program previous, and then we worked with a guy called Ben Wood, who did the aerodynamic package on the vehicle, and his concept for the car was, again, to reduce the frontal area. We had to keep all the bodywork as low as possible. So not only this asymmetric monocoque, but also our side pods, our engine bay, rear deck, all had to be minimum surface area, frontal area. And the compromise with that, the difficulty with that, is that you don't have anywhere to put your radiators. And so what we wanted to achieve was a very, very small radiator package in a small side pod. And if you look at the side pods on the O2S, they're not even stepping height. And the way Ben achieved that was by creating a very, very low pressure area behind the car and drawing air through the car. So I guess the common misconception with radiators and aerodynamics is that air's pushed through a radiator, and it's actually not. The way a radiator works most effectively is by having a big pressure differential across. And if you can present air to the front of the radiator and you've got a very low pressure behind it, you will suck air through the radiators. And that's what we did. If you look at the O2S, it's got this enormous whale tail mouth at the back of the car, and almost a Venturi. If you look at it in section, there's a dip in the middle, and that, like the diffuser underneath, it accelerates the air through the car. So we're actually creating a huge low pressure area behind, pulling air through the car and drawing air from the front of the car under the splitter, which also helps create downforce. So we're generating air from the front of the car through the radiators and out the back. And that was one of the things that sort of allowed us to achieve essentially a very, very low L over D for a non-coupe car. By March 2002, the car was fully designed. It was fully designed in terms of most parts for manufacturing had been released. We built monocoque. We crash tested the car. We had a full set of suspension, but at that point, no further work had continued, and we had got to the point where we'd sold 2 cars to customers, or we had agreement to sell 2 cars to a customer, but to finish the car we still needed to complete some aero mapping and some aero testing. We still needed to do some composite bodywork components, and there was quite a lot still to manufacture to be able to assemble and put the car together. So yeah, it was at that point it was designed to be a Volkswagen engined car as well. Reynard went bust, went into administration, and I mean I don't know all the details from at the time, all the circumstances around it, because I've learned subsequently that business is complex and brutal. But you know, essentially it became a victim of a market scenario really. IndyCar was a really, really interesting and lucrative place for Reynard to sell cars, and there's therefore had been quite a big focus on America and IndyCar. At the same time, and the reason why I guess IndyCar was so important, you know, most of Europe for the lower Formula categories were going to one make series. So Formula 3 had gone one make, Formula 3000 had gone one make, and as soon as you do that, you remove the opportunity for anybody to go and build cars and try and sell cars in those categories. So a lot of the markets had changed, but sadly, you know, in America we had the 9/11 event, and 9/11 event caused economic instability in America, and IndyCar was big business. There was some big sponsors involved in IndyCar. Drivers were being paid very, very well, and it all got a little bit out of hand, I guess, from a commercial point of view, to the point they felt it wasn't sustainable. And so the teams came together and decided that rather than buying new cars, new equipment all the time and competing with each other, there should be some stability in the regulations around chassis supply. And one of those was to I think it was a 3-year chassis rule. So now the cars had to be used for 3 years as a minimum. And that almost switched off the Reynard IndyCar market overnight. You'd gone from being able to supply 30, 35 cars a year plus spares to just a spares business. And as I understand it, the business was not able to restructure quickly enough. We'd gone from, you asked earlier how many people when I joined in '93. In '93 there were 60 or so people at Reynard. By the end there were well over 200, maybe 300 across the world, because we had locations in Indianapolis to support the IndyCar teams. We had 2 wind tunnel programs in the UK to stay competitive, because the other thing was Reynard dominated IndyCar, and the only way it dominated IndyCar was by staying ahead of the competition, and Lolo were always trying to get back in there, and the only way you could stay ahead was improve, more and more wind tunnel programs, more and more R&D activities, more and more engineers, more and more updates and developments, and so it was getting very expensive to operate as a product as well. But so there was a lot of people, a lot of facilities. We moved into new facilities in Brackley as well, to house all of that with the composites and the pattern making and CNC machining and CFD investment, wind tunnels. So the facilities at Brackley had expanded. So yeah, it was quite a big business at the end when it unfortunately toppled. During the administration process, the sports car program was sold to a company called International Racing Management, IRM, and the car was continued to be built as an IRM O2S. But now it was also with the support of Bill Gibson at Zytec for the engine. So the engine had gone to a V8, and myself, Will, pulled together the team that we'd been working with at Reynard, because this all happened very quickly during the admin process. And we pulled together the team with Zytec support, with IRM, and actually put everybody back almost in the office where they'd been based at Reynard before. We managed to do a deal with the landlords on that, and we continued to build the car. So we didn't have to move it anywhere. We carried on building it in the old Reynard facilities, but we did it with a bit of a smaller, more agile team, and the objective was to get the first car up running racing at Road America at Atlanta, Petit Le Mans, in 2002, which is about around October time. So it was still an LMP675 car, and it always, as I mentioned earlier, that as a customer car they need to be able to accommodate different engines. Yeah. And so there wasn't the V8, the Zytec V8 had already been packaged for that vehicle. The car had been package protected for the V8, but it wasn't our intention initially. It was going to be a Volkswagen car as the first off. So at that time we had manufactured bell housings that fitted the Volkswagen engine, so we needed to make the Zytec bell housing. That was pretty much the only changes. Everything else had already been designed. There were some configuration changes of exhaust systems and water cooling systems and so on that went in. But no, it was already, you know, reasonably well intended that engine was going to be packaged. I don't fully understand what happened next on everything, but IRM had a short-term objective to achieve certain things with that car and that project, which once they had done that, they had no further use for the project, and I think they couldn't see necessarily being a customer car constructor themselves. They were more associated with that single racing activity and sponsor activities. So Zytec was already a customer engine supplier, and I guess saw the opportunity to be a customer chassis supplier as well. And so Zytec continued the legacy of the O2S as a Zytec constructor as well as a Zytec engine manufacturer. When we set up the new team, or brought the team back to complete the chassis number 1 O2S, that's when Will and I set up KW Motorsport in order to help deliver that. And so Zytec had gone off and done their chassis engineering bit, which we weren't part of. They put their own team together for that. We were off doing KW Motorsport stuff. So there was a bit of a dwell between Zytec and IRM doing what they were doing with their project, and still around Chassis 1, which was now being run by John Nielsen in the FIA Championship. When John had finished running that car in the FIA Championship, the car came up for sale and Creation Autosportive bought that chassis. And at that point, with Zytec off doing their own engineering activities for the future of their project, we came on board with Creation to become their engineering partner to develop the what had now been called the DBA. So it had gone from the O2S, Reynard O2S, to the IRM O2S, to then when John Nielsen was running it, being a DBA. Traditionally, John Nielsen's team, Demblar Avis, named their cars DBAs, so it was a DBA 03S, and we came on board as an engineering partner with Creation Autosportive to help them understand that car. But essentially it was the same. At that point, very little had changed between the original O2S and the DBA 03S. So whilst we were at Reynard and part of the sports car team, or sports car environment, I suppose, we worked on the technical working group for the FIA for the regulations, and there were annual and other regular meetings that helped define what the future regulations were going to look like, and making sure that regulations reacted to things that were happening at the track and at events. And sports cars had, for some time, had a little bit of an aerodynamic instability that probably wasn't fully well understood or really acknowledged as being a safety problem. But there were a number of accidents. There was a Porsche GT1 that took off in Atlanta. There were the Mercedes GT1 cars that took off at Le Mans. And those are the sort of the famous ones. And then there were many other events where sports cars became unstable in certain conditions. And 2 of those were in testing with OEM cars. One of those events led to a driver's death, and it was becoming quite apparent that there were issues around the aerodynamic stability of sports cars. So the FIA quite rightly put together a working commission to fund and develop what was the what's the cause, and therefore how can we do something about it aerodynamically in terms of the regulations that make the cars safer. And there were a couple of safety issues that, or a couple of things happened. Firstly, there was a focus on the structure of the vehicles themselves to make sure that if they were compromised, that the safety cell protected the driver better. And so immediately, and these regulations were implemented in 2004, as you said. But the things that perhaps were most notably different outside between the 2 cars, previous regs and 2004 regs, was the safety cell. So you now went from the asymmetric single roll hoop was banned, and you now had to have a symmetrical rollover structure on both what they call the driver and passenger side of the car, although there's not room for a passenger. But the drivers do sit offset from the centre line. So that was the most noticeable external difference. But then the other aerodynamic changes that you could start to see when you look into detail is that the front and rear overhangs of the car were significantly reduced. We went smaller rear wings, and underneath the car, the bit that's less obvious was that we'd now gone from having a diffuser that started at the rear wheel centre line to a diffuser which was almost a bit more like a tunnel system, but diffusers that went much further forward on the underbody, and also, most importantly, the chassis, the floors were no longer completely flat. They now had a chamfered side to them at the point of the side pods to the centre of the car. And before that, LMP cars had this enormous 2 metre by 2 metre flat bottom, essentially. And what we did in the working group was we ran some wind tunnel tests, we ran some CFD models. All of this done by the constructors, people like us and Worth Research and Delta Motorsport. We're all putting research into this to support the FIA and help develop a set of regulations that were aimed at making the cars more stable, and most importantly, more stable in the circumstances that were unusual. So following a car closely behind and finding suddenly you've lost front downforce and the car lifts, or a puncture or a suspension failure which causes the car to take a strange attitude, which again would cause problems before. And the chamfered floor, the main objective of that is if then all else fails and the car is unstable and it starts to spin, instead of going 90 degrees to airflow and actually becoming a wing in its own right and generating lift, the chamfered floor was aimed at creating a neutral aerodynamic position so the cars were safer and easier to recover. The other bit that you'll notice, I guess, big visual difference was the fin in the middle of the engine cover, and that was a stability yaw to try and create some self-correcting measures, but also helps with this aerodynamic stability of the not becoming a wing. The ACO have always been very good at making sure regulatory impact doesn't decimate the grid. So they have good grandfathering rules, and there was no different with the introduction of 2004 aero regs. You could continue to run the old cars as long as you had taken some measures that again were defined by the working group to make them safer and also to slow the cars down. if you adopted the new rules, you had the full set of tools available to you in terms of how you could run the car. If you were grandfather in the car, you were probably penalised a bit in terms of power and performance. But there were such big differences between 2004 and before that very few constructors were able to immediately create a new regs car, and so there was about a 2-year period before we were starting to see complete new regs cars come in. But there was a middle ground that you could create called a hybrid. So not hybrid in terms of powertrain, but hybrid in terms of aero regs, where you could take an existing car and modify it and sit somewhere between the original spec and the new specs. But it was, I think 2006 onwards, you started to see completely new cars.
In 2004, there was a new entry using a derivative of the, I don't think it's unfair to say, kind of outdated 01Q in the form of the Nazamax. Do you know what the process was behind choosing that chassis as the basis for that car?
So I became involved in that project at the point where they'd chosen the chassis. And I think it was probably for the reasons that you just said. It wasn't in huge demand, so it's probably relatively cost effective. There wasn't a constructor around anymore to dictate how it's managed and how it's homologated. So I think it was a good candidate, actually. But also it was the way it was designed and the modularity of it meant that you could make the changes that were being proposed. And actually that car became a hybrid of a number of different technologies. So it was a Reynard 01Q chassis and body package. It ended up having in its first life a Reynard IndyCar rear end. So it was a good candidate for being a donor for that particular project. Probably because also being a Garage 56 car, it's not necessarily just about performance, it's about technology demonstration and other outputs. So with Creation Autosportif, I can't remember how many races I attended. Certainly every Le Mans. I mean, I did 9 Le Mans races in a row. I think Le Mans is just my favourite. I mean, there's some particular events around certain races that were memorable or fun, but I think the important thing for me was Le Mans was always the big annual event, and it always came around really quick. But I remember with the Nazamax car, I was on the pit wall with that car, so that was quite rare. With the Creation cars, there was already an engineering team that was on the pit wall, but I was on the pit wall with the Nazamax cars. I found that hard work. It's you've got to be awake for the 24 hours of the race, but you've also got to be awake for 10 hours before the race and 10 hours probably after the race. And every 13 laps, the car coming around, you've got to be alert and aware. But we had, I can't remember what year it was now that we ran the Nazamax. I think it was 2004. And we were running the Judd V10 biofuel. And as I say, it's hard work. Your brain's stretched as it is. And then we found that midway through the night, we had to make some unusual fuel calculations to cope with the inability or the availability of fuel and when it was going to be available to us, because we were running in Garage 56, which was right at the end of the pit lane, and it didn't have the same capacity fuel tanks as others. And we had perhaps been running a bit longer in the race than the ACO had expected us to continue to run for. And so we had to make some calculations about how we're going to manage the fuel and fuel efficiency, and that was a really tough thing to do in the middle of the night, 2 o'clock in the morning. But that's why endurance racing is so much fun, actually, because anything can happen. Although now it's even more, I suspect it's more difficult now because they are sprint races from beginning to end. But yeah, Le Mans been my passion.
I want to talk briefly about the Viper GTSR project. It's my understanding that car was constructed by Orica in France, and Reynard was tasked with building the chassis. How correct is that as an assessment, and what was Reynard's involvement?
So that was quite early on in my time at Reynard, and that was a project that was the chief engineer on that project was a guy called Paul Brown, who I mentioned earlier. Now we definitely had cars at Reynard, and we certainly did all the engineering and the wind tunnel development and the parts design and development. And I think we must have built some of the early cars at Reynard. But yeah, Orica went on to then run those cars for Mopar as a customer. And of course that car won at Daytona outright with, I think, Olivier Beretta driving. But yeah, so there was, we were involved in several iterations of that as well, because we also built a wind tunnel program for the new Viper that came out several years later, which never actually made it to a race car, I don't think. So that was again one of the early cars to be using 3D CAD. We used CATIA around that car. Although I remember now the very first composite bodywork was done in 2D sections and was built by our pattern makers, Protoform Patterns in Brackley. But I remember that pattern work being built. I think the car was it's quite conventional in its engineering. It used as much F3000 IndyCar knowledge as Reynard knew at the time to implement into suspension systems, fabricated uprights, etc. But the bit that Reynard was, I guess, focused on every single car they were doing at that point was aerodynamics, and so we had a wind tunnel program, and it had, I think, probably for its period, quite advanced aerodynamics in terms of being able to generate downforce.
And what were the key differences in the kind of development pipeline for a GT car as opposed to a later LMP car? Is there a significant difference, or are they more similar than people would expect?
No, they're very similar. I think the thing about a GT car or a touring car actually is that the difficulty is you've got some constraints in that the original geometry is set, and you've got a set of regulations you need to try and force that car to fit. And when you're doing an LMP car from the ground up, you don't. You have a set of regulations to work around and a bit more freedom. So I think those are all the difficult. The challenge is how far can you go with some of the aerodynamic devices to go. For example, on a touring car, same with a GT car, typically your front splitter area, the aerodynamic section at the front of the car, you're only allowed to go to a certain Z height on the bumper, and everything above that has to remain stock. So those are the challenges. I don't think the timelines are necessarily different between the two. In engineering and development like that, you always use whatever time is available to you and more. So if it just defines sort of how much effort you're able to put into it, I suppose. But no, the timelines doesn't change. It's just that the approach to it has to be different. So I think Viper's probably still front engine. Okay. Because you were working with a existing GT car chassis, the chassis platform itself didn't change an awful lot. The Esperanti was quite unique, so you had a carbon chassis at the very front of the car. We had the engine as far back as possible to the carbon monocell, and then there was a transaxle at the back of the car, and another with a carbon prop shaft down between the monocoque and the engine. So that was much more a ground-up race car design that looked like a GT car. So I guess you could say Viper and Esperanti don't look dissimilar in concept because they're long bonnet, front-engined cars. But no, the Esperanti was a back-to-front Formula One car, and it was it was quite advanced actually. Did it compromise development? Personally, I think you could probably build a better balanced car as a mid-engine. Did it compromise development? We still developed it as far as we could. Could the car been quicker if it was mid-engined? Maybe. There were some peculiarities about that car, if you speak to the drivers, about being positioned so far back, so sitting on the rear axle almost, and driving it. But the car was competitive in terms of its aerodynamic performance and so on. The fact that Don wanted it to be a front engine car, I didn't know Don particularly well in the early days, but I know he was very much of the opinion that an engine needs to be in the front of a car. That's how the Esperanti road cars that Danny was building were based on, and Don will always challenge, if you challenged him on why you put the engine in the front, he would say you'd never see a horse pushing a cart, which is quite true.
Very true.
But what you're missing the fact that the actual horse in this case was the engine, was the transaxle at the back with the rear driven wheels.
Don't tell Don.
So it was being pushed, but no, that's what he would always say. Q9 hybrid. So I mean, the original Panos obviously wasn't called Q anything. So no, Q9 hybrid. It never really got called that because it was always called Sparky. That was way ahead of its time. Again, if you sort of think about the thing we were talking about with the Chrysler Patriot concept, the Sparky had a hybrid system with a battery technology that was nowhere near ready for that kind of application. And now we didn't have lithium-ion polymer batteries then, so it was an attempt to do something that now we take for granted. Most race series have got some kind of hybridization in them, I think. But it was a challenge to implement because whilst you achieved a significant performance benefit in terms of the boost that the electric motor, the power from the electric motor could give you, we had challenges in managing that structurally in the gearbox. We also had challenges with the fact that the onboard batteries to do this were nowhere near efficient in terms of mass. So everything that we put into the car to provide the extra performance was defeated by the fact we were carrying significant extra mass.
What was Reynard's involvement in the subsequent LMP1 Roadster S project?
0. Yeah, no, it's so the last, I can't remember what the last activities were, but no, that project was designed, the Roadster was designed by Andy Thorby and was built by Elan Composites and Don's empire that he was building for building his own race cars. So he had visions of being involved in IndyCar and sports car racing. So they built a facility in the States.
You were chief designer on the Ford Mondeo BTCC car, and you said that was the only car that you were the chief designer for. How different was it going from being the chief designer on the Ford Mondeo to managing a department that was building, multiple of these projects simultaneously?
So it wasn't easy to adapt, and it wasn't necessarily easy to do because I was quite young at the time, didn't have an awful lot of experience of people and doing that, and I think probably also, you're starting to move away from a cohort of people that you work with to then being a manager of that cohort, and that can be a bit of a challenge. But it wasn't an unnatural move for me because I actually don't think I was very good as a chief designer. So it wasn't going to be, there were better people that I could work with and choose to employ to do those projects and to do those jobs. I very much like the concept, the challenge and kind of the new strategy, innovation, but actually chief designer and the very, very technical element of chief designer was I didn't enjoy that so much. I like laying out the grand scheme and the overall concept. So always working with other people to do the details. And we had small teams of people as well in those days, not like we do now. I imagine being a chief designer on bigger projects is much more difficult than it was for me to be a technical manager running several projects.
What was the Ford Indigo?
So Ford Indigo was, well, I don't know who dreamed it up and whose idea it was, but and Adrian would be able to tell you straight from the horse's mouth. But the concept of that project, as I understand it, was Ford wanted to build a concept car. It was quite common for OEMs to build concept cars for major automotive events to demonstrate their vision and the future and what future of automotive might look like. But they're always just static cars. And I think Adrian might have said, well, rather than build something that just is static, why don't we build a real prototype that actually you can drive onto the stage? Maybe it was somebody at Ford that came up with that idea, I don't know. But the idea was to build, because Reynard was now being extremely successful in the States in IndyCar, and the idea was to build an IndyCar for the road. So that was the concept. And true to form, at Reynard we built the car as a one-off prototype with a IndyCar engine, IndyCar gearbox, and a carbon monocoque, and it was driven onto the stage at Detroit Motor Show as a concept demonstrator, but as a real working car. And that project was where Adrian met Otmar Safner. Otmar was working at Ford as a program manager, and that was one of the projects he was working on.
What was the Virgin Atlantic Seat project like, and how surprised were you to receive that?
Yeah, so that was one of my early projects as coming out of graduate engineering role into special projects. Again, I probably can't remember the entire background to it, but I can't remember, unfortunately, the gentleman's name or the young lad's name, but this was a student project, a university product design project that this student had been doing with Virgin Atlantic Direct, and he was coming up. The challenge was to reinvent upper class seating, and he'd come up with this concept that Virgin Atlantic were obviously quite interested in, which was you could increase the number of seats that you could put into the upper class cabin as long as you kept them at a 55-inch pitch. But in doing so, you couldn't get the same level of comfort. So his concept was creating essentially a submarine bed type technology. So it was a lie flat bed that went underneath the seat in front. And one of the bits that was quite innovative about that was the recognition that an airplane doesn't fly flat, it flies slightly nose up. So if you're flying slightly nose up and you want your seat or your bed flat, it means it's at an angle. So relative to the airframe, you can start to stagger your seats like this. One goes under the one in front. So they come up with this concept of the product design, and it needed implementing. And so it came to Reynard. Adrian put it into special projects as a challenge to see how we could build the prototypes, and we built a prototype for Virgin, which there were several challenges. One, to achieve the ergonomics and the kinematics of the seat, but also with a minimum number of motors and with the lightest weight structures, because mass is fuel in aircraft. So those were the two challenges, and of course, around racing technology, kinematics and lightweight structures are sort of bread and butter. So I think that's probably why it came to Reynard to look at. And I worked there at the time. The technical director at Special Projects was a guy called John Piper. He was very much involved in implementing this project, and we built the prototypes, and it went on to become Reynard Aviation as a joint venture between Reynard and Virgin Atlantic. So they built, I don't know how many seats they ended up building and putting into service, but certainly the upper class cabin of Virgin Atlantic were these seats for a very long time. And we did get involved in designing the manufacturing process for professional ice skates for ice hockey in Canada. But no, most of the projects were automotive related. So we did projects for OEMs where we would build prototype vehicles. For Range Rover, for example, when they were changing their suspension system, you'd build mule vehicles. But everything else was kind of motorsport related.
You were one of the founders of KW Motorsport. What, in the early days, was KW Motorsport's remit? What were you doing on a day-to-day?
Trying to survive, really. So it was, rather than going and finding a proper job, we decided to become freelance, I think is what you call it these days. But we set up KW Motorsport in order to facilitate continuing to be engineering in motorsport in the same way that we had at Reynard. So I guess there were other opportunities to go and find a proper job. But I saw the opportunity that there was some customers that needed our support immediately around sports car racing, and similarly in IndyCar racing. And a colleague of mine from Reynard at the same time, Simon Dowson, had set up his company in the same way, Oxford Racing Developments, that went on to become Delta. So that was the primary reason, was to start creating something. It was the opportunity to start creating something that perhaps I wouldn't have been brave enough to do whilst I was employed and got a good job that I enjoyed anyway. So we set up KW Motorsport, and our first role was to work with the O2S, and then Will also started working in the States with IndyCar, which was where he'd been previously before he came to Reynard. So those were the things we did. It was freelance engineering. It was the first time people were kind of taking the opportunity to work from home. We hadn't got internet. It was still dial-up. But we were communicating via email. We had computer stations at home, and we could work remotely and bring everything together at our customers' premises, which was typically a race team factory anyway.
And during this time, 2004, 2005-ish, am I correct in saying you were brought on as a consultant for the development of the McLaren MP412C monocoque chassis, is that right?
Yeah, so I think that was 2004. So a guy called Neil Hanneman, who had been technical director at Chrysler when we did the Viper GT1 project and several other things that we'd done for Chrysler. He was now technical director at McLaren Automotive, and he called me up and said that there was an opportunity. They were looking for a principal engineer for composite chassis design, body structures. But at the time I was flat out with Croatian Autosportive, a project called the ProTran RS06, which was another LMP car, the Nazamax. So I wasn't really looking for a full-time job, but I said I'd go and help out. So I did a few days a week consultancy down at MTC. That was my first time down with McLaren. So I went and did a few days a week with them whilst they were finding somebody full-time to take on the role. But the remit was the feasibility and early concept design of what went on to become the carbon monocell before anything had actually been manufactured. It was a very small team of people working on that project at the time. There was the core business was the McLaren Mercedes SLR. KW Motorsport was set up in 2002, I think it was 2003, 2002, and one of the challenges I had with KW Motorsport is it wasn't very scalable because it was really selling consultancy time, my own time around sports car racing and wheels into IndyCar. But I was quite often getting involved in projects that weren't directly motorsport related as well. So I had these two things. I wanted to build a bigger business that was more scalable and wasn't just about me. And I wanted to be able to do projects that weren't just motorsport related. And I guess around 2010, 2011 time, we were doing a quite special automated machine design project for an industrial customer, but it was leveraging composites. So it was a complete composite structure to solve a non-motorsport industrial problem. And our invoices and conversations between the companies were going, our email addresses were KW Motorsport, our invoices and our company was KW Motorsport, and it perhaps didn't make complete sense to everybody why a motorsport company was being contracted to do this job. So that also flagged to me we needed probably a different entity to deliver those sort of projects, the non-motorsport projects, and one that I could see perhaps had more scale and capability than the motorsports alone. So 2012, off the back of that industrial program, we secured another contract that required another industrial program around composites and automation, and I decided at that point to put it all through a new entity called KW Special Projects. And obviously the special projects bit, do what it says on the tin kind of activity, but it didn't preclude us from doing motorsport activities under that banner, but it made much more sense for us to be able to do automation, industrial machine, automotive even under that banner. The important bit to remember is it's all engineering. So at KWSP we had as you said, a lot of different projects, all in quite different sectors, and it was really difficult for anyone from the outside looking in to say, well, what's the common theme? How can you be designing a bicycle for professional cycling and a race car at the same time? What they got in common? Well, the bit they've all got in common is engineering. So it's all just problem solving and applied problem solving. So the tools you use are the same: CAD systems, CFD, aerodynamics, if they're applicable. So all those tools are available. You just got to use them in a different way. And so the skill that I guess I brought and put into the team was: don't have any preconceived ideas about what the solutions are. Don't worry that you don't know anything necessarily about the sectors that we're being asked to work in, because our customers are already the expert. what you're doing is solving a problem they don't know how to solve. And the best example of that was this machine design that we started off doing for a company called Xenia in Cambridge, where it was an industrial inkjet machine printing textures and patterns onto ceramic tiles. Sounds really boring, but they knew their technology and industry really well. They knew about ink, they knew about inkjet, and they knew about what the product needed to do. What they didn't understand was what new technologies might be out there to help them deliver some of the other parts of that infrastructure. And one of them was that they were building a very, very large, what they call print engine, that has 120 print heads in it that all need to be controlled very, very accurately, all temperature controlled, a load of plumbing and electronics, all this sort of stuff that they typically would build into an aluminium and steel, what they call carriage. And that carriage, for this big, as they were getting bigger and bigger, these print engines, they were becoming heavier, so heavy and so large that they couldn't sustain their own weight, and they would deflect, and they would also be sensitive to heat. So if you put them in a factory that's 5 degrees cooler, suddenly everything contracts. Put them in a factory that's 5 degrees hotter, and everything gets bigger, and all your tolerances go out. And they had all these challenges, and they didn't know how to solve it because they were only familiar with using metal. And we came in and said, I went in and said, why don't you use carbon fibre? Because carbon fibre has a much lower thermal expansion. It's much easier to mould and make the shapes you want, and it's much stiffer for less mass. And they said, well, we don't know anything about carbon fibre. And so that was the light bulb moment, I guess, that you can actually transfer technology from advanced industries like motorsport into other sectors that you might consider not to be as advanced but need to be. And so we designed a complete carbon fibre structure for them it went from, I think their aluminium and steel structures were something close to 1,000 kilos. Wasn't stiff enough, and it expanded a lot. And it was complex to make. And we went to something that was 140 kilos in carbon fibre. We basically built a monocoque. It was big, it was almost as big as this table. It didn't expand. It had all of the, because it was moulded, it had all the brackets and details and cable routings and everything, and the cooling ducts were all moulded into it. And it ended up being cheaper and easier to install. So, I didn't need to know anything about inkjet or ceramic tile printing to solve that problem. So, that's the common bit was solving the problems. It's the same whether you're talking about skeleton or cycling or cars and motorsport. But it is pretty cool that in that career we've been able to sort of be involved in competitive race cars, racing at Le Mans, winning IndyCar championships, being involved in Formula One teams that are winning Formula One World Championships, and then at the same time winning gold and bronze medal at the Winter Olympics. Formula One teams are very demanding. The rate of development and R&D in Formula One is fast, very fast. And I'm not the first person to have said it. It's just a thing in Formula One and racing. You've got to be ready on Sunday, and if you're not, the race won't wait for you. So it's just a demanding environment. It's not to say other sectors aren't. I mean, it's no different. The Olympics doesn't move, so you've got to be ready for the Olympics. So it's not just Formula One. It's just any competitive environment where time is critical. Then you have those constraints, because what you always want to do, to get the best performance, whether it's skeleton or whether it's a Formula One car, is you need to maximise your development time and research time, minimise your manufacturing time, so that you can maximise the research time and still achieve that end date. So, it's competition. You always need to be ahead of the game.
What was yours and the DMC's involvement in the hypercar project?
It's one of the first new car companies to build a hypercar for the road for a long time, and with an expected high degree of success as well. So not a fly-by-night business. But one of the opportunities with something like that, a bit like when Tesla came to market with electrification, is you got no preconceived or legacy carryover or concepts or people even as to how you're going to approach that. So I was very fortunate to get involved with the relatively small engineering team right at the beginning of the program, at the same time that we were setting up the concept of the DMC, before we actually opened the doors, but whilst the DMC was being put together. And we talked about the benefits of additive manufacturing, And there were some immediate low-hanging opportunities, so prototyping essentially, which is what people think of 3D printing mostly for. And by getting involved with those engineers early in that process and then educating and informing what the benefits are and what the technologies are and the methodologies available to them, we suddenly started to see more and more parts being developed. But the real benefits, the two real benefits that they've seen from using additive manufacturing have been lightweighting, which is absolutely a key part of the philosophy of the car, and also zero tooling concepts, where you can manufacture parts direct without need for any tooling, which goes back to that bit I mentioned before about keeping your development options open, because you haven't got to commit to tooling, so you've got much longer research time available to you, and also cost in terms of tooling investment.
What does the future look like for the DMC, and what does the future look like for you?
So I mean, for the DMC, the future is going to be less and less about motorsport and automotive. We're quite dependent on motorsport and automotive at the moment, primarily because those, particularly in F1, but also in sort of the hypercar marketplace, there's a need, and it's kind of it's the right tech at the right moment for those projects, and they can the projects can afford them. So they're the early adopters and ones that we can convert quite quickly. So, you know, we've got something like 300 parts on 2 separate hypercars, both across metals and polymers, and then a vast amount of F1 stuff that adopts additive, both metals and polymers. But where we're going with it next, and where the industry's going, is more towards aerospace, space, defence, probably eventually into renewables and oil and gas sort of industries. And there's some interesting products that are now only becoming possible through additive manufacturing. So in space, for example, rocket engines now, some of the most advanced rocket engines that are being used in commercial space flight are only manufacturable now through additive manufacturing. And then other products like heat exchangers and thermal management systems that have started. There are companies specifically dedicated to using additive for thermal management. So it's becoming a more widely adopted manufacturing process, rather than prototyping and model making, which is where it started 20, 30 years ago. You know, now we're seeing real world applications that can only be manufactured using additive. And so where DMC wants to be is to be a supply chain for those customers. So whether it be for defence tier 1 primes, or whether it be for automotive, where we want to have a distributed supply chain for additive manufacturing. All comes back to that digitisation bit. I mean, none of this would be possible until we've gone to 3D CAD modelling, for example. But now you're seeing, without getting boring and geeky, but you know, we used to exclusively manufacture things from CAD models, but with additive manufacturing, you can now manufacture things from code. So a complex heat exchanger, for example, which has got a very, very mathematically defined core and structure, it's almost impossible to model it in a CAD. And you don't need to model it in CAD, because you can actually define how the lasers manufacture that part just purely from code.
Is your future here?
Yes and no. So I'm not particularly interested in long-term, in-deep running business. I like creating new stuff. And so it's all about building a team here that can run the business day to day, and then how do we scale the business into other sectors, and how do we potentially clone the DMC and put other DMCs around the world, or even in space. But also, you know, car programs and car projects, and I guess my ultimate ambition is to get back to Le Mans again, before I'm too old to do it. But yeah, Le Mans racing, and combining Le Mans racing with things like we've done in hypercar market in terms of building customer cars. So Le Mans racing, customer cars, and then leveraging additive manufacturing and new manufacturing technologies across those platforms, whether it be for us directly or whether it be for an OEM, is where I want to be.
Brilliant. Kieron, thank you.
Thank you.
A big thank you to Kieron for taking the time to sit down with me for this interview, and to Ian Howe for helping to organise it. The DMC is an incredible place, by the way. While I was there, I was lucky enough to have the opportunity to tour their building. The facilities they have and the objects they're able to make are really, truly impressive. I'm not sure how much I can say about any of their specific projects, but I will say after seeing what they do, it doesn't surprise me that some of the most cutting-edge automotive engineering projects find themselves at the DMC's door. I hope you found this conversation as interesting as I did. If you've made it this far, tap the like button and subscribe. It's completely free. Thank you to all our channel members for supporting Automobilistic, it means the world. If you want to support us directly and help us with more big projects like this one in the future, consider clicking the join button below. You also get early access to all future uploads as well. Thanks for watching, and until next time, goodbye.